Hello participants, I welcome all of you in this lecture of advanced libraries in which we will discuss Numpy array, which is very important libraries as far as data science is concerned. So in current lecture, we will discuss basic concept of Numpy. Numpy attributes, there are certain attributes of Numpy like shape, dimension and so on. We'll discuss how to slice certain part from the Numpy array as far as one-dimensional, two-dimensional, and three-dimensional arrays are concerned. Then we'll discuss Numpy copy and view, how copy and view are different. And then we'll discuss how to iterate Numpy array. And finally, we'll discuss linear algebra operations to n-dimensional arrays without using for loops. How can we apply linear algebra operations on n-dimensional arrays? So, what is Numpy? Numpy stands for numerical Python. It is actually a library consisting of multi-dimensional array objects. A multi-dimensional, it means you can have one-dimensional array, two-dimensional, even n-dimensional array. You can create n-dimensional array using Numpy. And also it provides a collection of routines for processing those arrays. So it has several routines that are actually useful to process those arrays. So, some routines are like, you can directly calculate a mean, median, mode, and so on. So there are several routines as well. Using Numpy, mathematical and logical operations on array can be performed very efficiently. If you want to perform, like, let's say I want to perform transpose of a matrix, or if I want to multiply two matrices, or I need to add two matrices, so I can directly using single statement I can calculate matrix multiplication, matrix addition, and so on. Unlike Java, C, C++, there we need to write different loops, right? If we are using, suppose I need to calculate matrix multiplication in using Java, so I need to write two different loops for that purpose, right? And similarly for other languages as well. So, but in Numpy, using single statement, I can calculate all these mathematical operations. Then there are certain ways through which you can create the Numpy array. So I can create Numpy array using a special method of Numpy, that is np.array. Similarly, I can create Numpy array using np.0. So if I need to create a Numpy array of having zeros only, then I can use np.zeros. Similarly, let me select pen first. Oh, I'm selecting pen here. Similarly, if I need to, I can use np.ones as well. So np.ones is to create a Numpy array of having ones only, and so on. So there are several methods. Similarly, there are certain methods for random number generation using random numbers. If I want to create a array of random numbers, if I want to create a Numpy array of random integers, random floats. So all these, there are certain methods are available in Numpy. So Numpy gives an enormous range of fast and efficient ways of creating arrays and manipulating numerical data inside them. So it is very important library as far as whole data science is concerned. Now, if we need to find out the dimensions actually, so how Numpy treat dimensions. So here in this diagram, dimension 0 actually tells about the I would say number of tables. So let's say this is the very first table, and similarly you could have more. So this dimension 0 is actually for number of two-dimensional arrays, right? Number of two-dimensional arrays, and the dimension 1 actually tells about the rows of a particular 2D array, right? So this is row 1, and if we are taking 0 index, since so this would be the 0 index row, first index, and then second index. And dimension 2 is for columns. So dimension 0 is for 2D arrays. Dimension 1 is for arrays, right? Individual arrays, like in this case. And dimension 2 is for columns, right? So like in this case, if I need to find out, if I need to fetch this particular value, so this is as far as dimension 0 is concerned, so I would write here 0, since this is very first 2D array. And if I need to find out the rows, so in this case, the rows would be 1, right? And the column number is 0, 1, 2. So this one is the 2. So in this way, you can find out the dimension. So this just we need to remember, dimension 0 is for 2D arrays, or you could say tables in lay terms, and dimension 1 is for rows, and dimension 2 is for columns. So NumPy is having an n-dimensional array type called nd array. So whenever we create a array using NumPy library, so actually it creates a nd array. Nd array describes the collection of items of the same type. Actually, the beauty with a NumPy is the data inside the NumPy array is supposed to be same type. Although you can declare different type of data as well, but we used to save the similar data type inside the NumPy array. Items in the collection can be accessed using a zero-based index, like we have seen in Python list, and similarly dictionary. So we have used zero-based index in case of list, not in dictionary. Sorry. In case of list, we have seen zero based index. Similarly for string and for tuple and so on. In NumPy, dimensions are called axes. One thing is need to be remembered here. Every dimension is actually called here axis. So axis 0 is in case of 3-dimensional array, axis 0 is your dimension 0, right? That is tables in your 3D array, or you could say 2-dimensional array. Axis 1 is actually rows, and axis 2 is columns. So the importance of these axes we'll discuss in coming slides. The basic nd array is created using an array function. So like in this case, you can create a NumPy array. Object, it means the data that you want to pass. Let's say the object is 5, 3, 2, 6, 7. So this is actually an object. And data type is you can supply any data type, whether it is integer, float, complex number, and different type of integers, actually 8 bits integer, 16 bit integer, 32 bits integer. Similarly, you are having float value, unsigned integer. So there are several data types, and in that nd mean it means number of dimension. So number of dimension, it means here it is given number of dimension 2. It means it is a 2D array. So it is supposed to create a 2D array in this case. There are several attributes of NumPy array. The very first here is shape. Shape, actually this array attribute, it is a tuple consisting of array dimension. So shape is it returns the dimension of the your NumPy array, whether it is 2, 3, 1. Okay, so this is the shape, or it is 2, 1. It means 2 row and 1 column, right? Similarly, 3, 5, it means 3 rows and 5 columns. So this return, suppose we have created a NumPy array, and you need to find out what is the shape of this array. So you can print this value and you will get the shape. You can also use this particular shape to modify the dimension as well, or you could say resize the array. Suppose you have created an array of 2, 3, 2, right? So you have created this array, Numpy array. Then you can, using shape, you can modify it to 6, 2, right? 6, 2, because the number of elements will be same in both the arrays. So we can modify the shape of the array. Now there is one more attribute, that is endim. Endim actually it prints the dimension. Dimension, it means 2 dimension, 3 dimension, 1 dimension. So this is 2 dimension, this one is 3 dimension. So endim would return 3 in this case, and for this, in this case, it would return 2, right? Then we have nd array size. If you want to find out the size, number of elements in your nd array, Numpy array, so you can use this particular attribute, that is size. Now, if you want to specify a particular data type, then or you could say if you want to display the type of data in your Numpy array, so you can use this attribute, right? So it would display it would describe the type of the elements in your array. Similarly, you are having item size. It means the size in bytes of each element of the array. So there is a difference between item size and size. Size actually tells the total number of elements in your Numpy array, and item size actually tells about the individual elements size, right? So for example, here it hasn't mentioned here. Suppose you have used float 64 as a data type in your Numpy array. So you can calculate the item size. So the item size is actually 64 divided by 8. So 8 it would be the item size in this case, if you are using float 64. Similarly, if you are using let's say integer 32, then the item size would be 4, right? 4 bytes actually. So like in this case, I can also use shape to resize my array. So like in this case, it is having it is 3-dimensional array, 3-dimensional Numpy array, and the total number of elements is actually the dimension of this array would be 2, 2, 3, right? So this is the dimension. Now it can be modified to in this manner as well. It has been reshaped to 2 cross 3 cross 2, right? So the number of elements would remain same, but the dimension would be changed in this case. So there is one more attribute that we discussed, endim. So there are certain examples here. So in this case, this is a 1-dimensional array. So it would create a 1-dimensional array. So you can print this value, so it would give you 1. Similarly, you can reshape a particular, since this is a 1-dimensional array, this can be reshaped to 3-dimensional array, and you can observe it 2 cross 4 cross 3. So the number of elements are same. So this can be reshaped, and the dimension would be in this case 3. Right? So this is the way you can utilize endim. So, but using endim, you cannot modify the dimension. Endim would just be used to display the content, right? But using shape, you can modify the dimension of your Numpy array. Like in this case, Numpy item size, there are certain examples here. So I am using data type as integer. It actually allows different type of data types, like np dot int 16, np dot float, then 32, and so on. So in this way, you can utilize, you can mention different data type. And so item size will actually give you individual element size. Like in this case, it would return 1. Since it is having int 8, so 8 by 8, 1. So 1 would be written in this case. So individual item is having size of 1 byte. So these are certain data type that you can use. We can create a NumPy array of Boolean data type, integer data type, and then we are having C type of integer as well. Then you can use int 8, 16, 32, 64, and unsigned integer as well, 8-bit unsigned integer, 16-bit unsigned integer. Similarly, you can have float data type as well, and complex data type as well. So it is very very special data type. If you would mention a complex data type, so automatically each and every element would be converted into complex number, and it is having different version as well, complex 64 and complex 128. So 64 actually it is represented by two 32-bit floats, that is real and imaginary components. So each complex number contains real and imaginary part. So there are certain examples here in this slide. So you can see here, if I am using data type as complex, then I can, so all these numbers would be automatically converted to complex number. So all the element would be in complex number. So let me switch to ideally where I would explore how to create NumPy array and how to change its shape and so on. I'm switching to ideally. So here I'm trying to create a NumPy array. So first I need to import NumPy as np, right? And I have to create an array NumPy array np dot array. Let's say I'm creating a we are having a list of value, a list of integer, let's say 3, 4, 5, 8, and then 11 and 12, 18, 20. It is having elements as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me add some more elements. So it is having 12 elements in this case, right? Let me print this one. Print. So I am trying to print this value. Okay, so actually I need to install NumPy first, right? Then I can use, first I need to install the NumPy here. Let me load first, then I will discuss this problem. Now I have installed NumPy array here in the system. So you can install your NumPy array by executing this command. So py, and py stands for Python, pip install and then NumPy. So once I would press this one, so NumPy would be installed. It would take some time, let's say 1 or 2 minutes. So it would be installed here, right? So since or you can use Colab directly, since from next week onwards we will move to Colab. But as of now, I want to install NumPy to my system so that I can use NumPy using ideally. So now it has been installed here, and let me write code here. So I have installed NumPy, and so import first statement I need to write import numpy as np, and I need to create an array np dot array, and the object should be list of elements, list of integers. So I'm writing here 14, 2, 4, 6, 8, and then 11, 3, 5, 7. So how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and then 11 and 12, right? So let me print this one. Print a double R, and then so first I need to save it, right? And where I need to save, so here is my file, save. So you can see here, so this is actually a numpy array. Now I will check the dimension of this array. So ndim, so you can guess what should be the dimension of this array. So this is one dimensional array since it is having just single row. So it is actually a one dimensional array. Now I can modify it to, I can reshape it. I just display the shape first. Shape. So shape would give me. So it is 12. It means only 12 values are there. So it is actually a list, right? Actually, this is not list. This is the numpy array having 12 elements only. So it is a one dimensional array. Now I can find out different D type. So D type actually would tell me the type of the data, right? So it is integer 32. By default, it takes integer 32. I can also modify here D type is equal to complex, and I can modify it here array. Let's say I'm displaying here array, right? So you can observe now each and every element is complex number. 12 plus 0 j, then 14 plus 0 j. Since the imaginary part is 0 here in this case, since I have considered only integers, so in this way it is being displayed here. But all the numbers are complex number, right? I can modify it to int only, right? Int 64, int 32. So let me select int 32. Sorry, it won't read. I need to use np dot int 32. So this is it. Now the data type is int 32, right? Similarly, if I need to select use float 64, right? So these are floats now. So in this way, I can modify my data type. So let it be default mode, and now I can modify the shape as well, right? I will write here r dot shape, right? Shape is equal to, I am having 12 elements. I can write 6 2, 6 cross 2. So it would have 6 row and 2 columns. So you can see here, it has now converted in this dimension. I can also modify it to 3 dimension. 3, 2, 2. 3 cross 2 cross 2. So now it has modified in this format. So the very first dimension, the very first table, second one, and third one. So in this way, we can have we can change the shape, and we can explore different attributes of numpy array. Now I'm switching to PPT now. So we have seen how we can modify shape of the NumPy array. Now we'll discuss array slicing. So you might have seen since we have already discussed this particular topic in list and tuples and so on. So slicing is actually a mechanism to extract certain part of the array. So slicing in Python means taking elements from one given index to another given index. So in case of slicing, you would be providing with the index actually index values. So on the basis of that, you would actually extract the data. So in case of one dimensional array, in this way you can take slice of NumPy array. So start is the by default it is actually 0, right? But you can mention the start value. Similarly, by default the end value is the length of your NumPy array, but you can modify it to some other. Let's say my NumPy array is ARR, so I can give here 2 and then colon 6. So it means the element would be starting from the second third index till the fifth index. So if suppose I am having element as let's say my element is 5, 3, 8, 9, 12, 14 and then one more 16, right? So what should be the value of this array slice? It would give me 8, then 9, 8, 9 and then 12. So this is 2, 3, 4, 5 and then 14. So it would give me this value. In case of if we can also use step value as well to step is actually, if you do not pass step value, so this is considered as 1. But if you are modifying it to, suppose I am modifying I'm taking step as 2 here, right? So what would happen? The value would be 8, then 2 values forward. So this is 12 and that's it. So it would fetch these 2 values. So after every after interval of 2 values, so it would jump the next index and so on. So in this way you can use the step. Step is used to decide how you want to step forward, whether 1 step forward, 2 step forward, 3 step forward and so on. So actually in this case you would jump to the next element. So in this way you can slice certain element here. If something is not here in this case, so what is 0 is taken as a default value. If you are not supplying any value, in this case the left part is empty, so the default value is 0. Similarly you can extract data from backward as well. So -3, -1, so this is actually your -1, -2, index number is -1, -2, -3. So it would give me value as 5 and then 6 in this case. Similarly you can apply other features as well of slicing. And how to slice 2D array? So it is very similar to 1D array. Just you need to apply 2 different slice. 2 different slice. It means one for row and another for each column, right? And it is very similar to 1D. So trait is this one is for array and this one is for column. Like in this case, what it would fetch? So 0 and 1 row. So both the rows in this case, since it is having just 2 rows, and 2 is for column. So second number of column. So from both the row, you would fetch 2 and then sorry, not 2, it is 3 and then 8. So it would fetch 3 and 8 in this case. Similarly, you can fetch other values as well. So like in this case, how it works. So 1 column 3 for rows, it means rows is your first and second. So first row and then second row. So you need to consider these 2 rows. And now as far as column is concerned, so you need to consider this column that is present at index number 1 and then column at index number 2. So you need to consider these 2. So that's why these values would be, if you would print this particular slice, then this value would be printed here. Similarly, this is your 0 and 2, second row and 0th column, right? So this is the 3-dimensional array. So in this way, you can create your 3-dimensional array as well. So I have already told you, suppose you are having 1-dimensional array, so you can reshape it to 3-dimensional array. We have seen. Other way is to directly create 3-dimensional array in this format, right? So this is for a very first table, and then this one is the another table, and inside individual table you are having rows. So this is 3. There are 3 rows and 3 columns. Similarly, for the other dimension. If you need to perform slicing from the 3D array, so again you need to pass 3 different parameters inside the index operator. So this one is for the tables, the number of the table numbers. Actually, I'm treating this one as a table, right? So this is the very first table, and then this one is the second table. And inside each and every table, you are having certain rows and columns. So this is very first table. So this is 0th table, and this is first table, right? So first one, and then 0, it means for row. This is for row. This is for row. So 0th row and then first row. So it means 0th row and first row. And what about column? So column is first and second. So this value would be fixed, right? Similarly, other index as well, like in this case. Now we will discuss NumPy array copy versus view. So what's the difference between copy and view? So copy is a new array, and the view is just view of the original array. So if you want to create a copy of the array, so you can use copy function. So copy would create a new array and the original would not be disturbed. But as far as view is concerned, so you are not going to create a separate copy, just there would be a view, right? So the copy owns the data, and any changes made to the copy will not affect original array, and any changes made to the original array will not affect the copy as well, right? But as far as the view is concerned, the view does not own the data, right? And any changes made to the view will affect the original array and vice versa also. If you are changing the main array, then view would also be reflected. The change would also be reflected in view. Like in this case, this is the way to create a copy, right? And this is the way you can create the view. So if you are creating a copy, so if the main array is changed, then the change would not be reflected in the copy array. Like in this case, the main array is being changed here, right? But this will not be affected in this particular array, NumPy array. But in this case, since this has been changed, the original array has been changed, and X is actually view of the original array. So this would be reflected in X as well. There is one more attribute in NumPy array, that is called base attributes. So copies own the data and view does not own the data, that we know. But how can we check this, that this particular NumPy array is copied and this NumPy array is view? So how to check this in programming? So every NumPy array has the attribute base that returns none if the array owns the data. If array owns the data, it means it will, base would be none. But if array do not own the data, like in this case of view, so it would return the base array. So like in this case, since X is a copy of the original NumPy array. If I would print X dot base, say it would return none, since X is having its own copy. But in case of Y, since Y is a view, so if I would print Y dot base, then it would print the base NumPy array, right? So that is the original object, which is A double R in this case. And how to iterate NumPy array? So that we have seen in list. So the way we iterate list, very similar iteration here in this NumPy array, but there is something different as far as dimension is concerned. Like in this case, if I need to iterate, so I can directly iterate. If my array is one dimension, I can directly iterate in this way. Since this is two dimension, so again I can iterate the similar way, but the X would contain individual rows. So the very first during the very first loop, the print X would print the whole data. In the next loop, the print would print the whole next rows actually, right? And in this case, since it is having two-dimensional array, the same these two are same array, but I'm instead of reading individual rows, I'm trying to read individual content of the row, right? So this outer loop is for individual rows, and this inner loop is for getting the individual elements of the row, right? Each and every row. So in this way, I can fetch individual content of the data, individual content of the NumPy array. So let me move to the IDE where I would try to show you how we can iterate NumPy array. So I am having this array, and I am reshaping it to 6 row 2 column, or you could say 2 row 6 column, right? Now I would iterate this one for I in array and print I. So what it would print? What do you think? What should it print? So first it would print the first row and then next row, right? So only this loop has been executed 2 times only, right? So at first iteration, it has printed the very first row, and next iteration, it has printed the next row. Now I can modify it to read individual content. So for j in I, it means I want to read individual element from each and every row, and I would write here print j. So you can see here, so individual elements have been read in this case. So I'm stopping here this lecture. So what we have discussed till now, we have seen the basics of NumPy, and we discussed different attributes of NumPy. So we discussed shape, endim for dimension, and then data type, d type for finding the data type. Then similarly, we have discussed other attributes like base attribute is one more that we discussed, base attributes, then size, item size. So there are different attributes that we discussed. And similarly, we discussed this array slicing as far as 1D, 2D and 3D is concerned, right? And we discussed NumPy copy and view, and what is the difference between copy and view, and how to iterate the NumPy array. So that we discussed in today's lecture. So thank you so much for joining this lecture. We will meet again in next lecture.